All right, let's go ahead and kick things off with the LSQ today, which it looks like about a third of the class, third of respondents had answered correctly. So question says, consider a firm that produces a single output in the long run, right? Assuming no fixed cost here, with profit function given by pi of p equals 1/3 p cubed. It says the price of output is P, input prices are constant and already built into that profit function. And the question is, which of the following is the expression for the firm's marginal cost curve? So hopefully you remember how we could use Hotellings to go from the profit function to the supply curve. That's the first thing you have to do here. And if you use Hotellings' lemma, right, means we're going to take the derivative of the profit function with respect to P. That should give us the supply curve. What does the supply curve have to be in this case? And you get Q equals what? Good. You get Q equals P squared, right? Just use your power rule to take that derivative. 3 comes in front, exponent goes down by 1. And then all you have to do to get the marginal cost curve is you have to solve the expression above for Q, meaning you're just inverting it. So if you do that, you should get, right, take the square root of both sides, solve for P, which means you should get Q to the 1/2 power, which is the same thing as the square root of Q. So if you got that, nicely done. You found the marginal cost curve from the profit function using Hotellings' lemma. With that being said, let's go ahead and just take a real quick look at the quiz results from this last week. Performance was pretty typical. I thought, okay. Average was right there around a 70, quite a few high scores, low score at the other end of the spectrum. Standard deviation of about 2 questions on this one, and the average time was about 46 minutes. So again, hopefully you're looking at this distribution, you're kind of seeing where you're falling relative to everybody else, relative to that average, which is going to wind up being around a B- at the end of the course. So let's go ahead, and I want to pick up about where we had left off last class, discussing this idea that is the, switch my share here. That was the weak axiom of revealed profit maximization. And we had left last class thinking about doing the following. Let's suppose we had observations from 2 periods. We were calling them period T and period S. In each period, we were able to observe the output produced, the amount of labor used, the price of output, and the price of labor. Okay, so the S subscript refers to one period, the T subscript refers to a different period. And we had wrapped up our last segment by suggesting that if we were actually maximizing profits in period T, okay, we argued it had to be the case that that profit in period T, right, if I'm maximizing profits, I'm behaving optimally, that had to be at least as good as what I would have made facing period T prices doing something different. So I want to be clear here that we're dealing with period T prices on both sides of this inequality. Okay. What was the optimal thing to do? Well, we were doing the optimal thing in period T, right? We're assuming the firms are profit maximizers. Okay. So we're doing the optimal thing in period T, which means if we do anything differently, right? If my Q is different than the one I chose in period T and my L is different than the one I chose in period T, then that cannot be optimal. And maybe it could be equally as optimal, but it certainly cannot make my profits go up relative to what I was making them. We can argue similarly that if you're optimizing in period S, right, now we're looking at all period S prices, right, in terms of the price of output and the price of labor, meaning if I'm maximizing profit in period S, then that must mean that the actions I took in period S, right, QS and LS, that must be at least as good as some other actions I could have taken. right? If I use QT and LT from the other period, that would not be profit maximizing when the prices have changed to the period as prices. Okay, so we have two conditions here that are consistent with us profit maximizing in both periods. Okay, what we're going to do is we're going to combine these into one condition. Okay? And the way we're going to do this is by moving the terms on the right of the period S inequality to the left side, and then moves the terms on the left side to the right side. So all that we're going to do here, and we're going to use the period S inequality. We're going to take this stuff and move it over here. Okay. And then we're going to take this stuff on the right and move it over to the left. Okay. If you do that, hopefully you're comfortable. This is how things will look. Okay. Just move stuff to the opposite side here. And what I'm going to do now is I'm going to add that line to the first inequality that we had. I'm going to add those together. Okay, so the first inequality on the left that the purple arrow is pointing to, that was the profit max condition in period T. On the right side of that double purple arrow now is still the period S inequality, just rewritten. So if we combine these things, what we will be doing is getting really one inequality, right, that summarizes the profit maximizing conditions in not one period, but both periods. Okay. So let's go ahead and we're going to add these things together. Okay. Meaning I'm going to take the left side here and I'm going to add it to the left side over here. Then we're going to take the right side over here and we're going to add it to the right side over here. Okay. Any problems with what we've done here so far? We'll just combine these two profit maximizing conditions. And what we're going to be able to do now is kind of recognize, hey, there are some terms we can group together and factor out. So let's go ahead and look at that carefully. And let's first start by simplifying the top equation here in the orange, at least the left-hand side of that inequality, and then we'll go ahead and tackle the bottom. But the top, anybody see some terms that we can factor out, some common factors in the orange expression? Yeah, good. There's a QT that we can pull out, right? And we can also factor out a what? Yeah, we look at Q here and a Q here. We could factor those out. Yeah, we could also factor out the L's. Okay. So if we do that, hopefully this makes sense, right? We have the prices, the wages multiplied by L here factored out. And then we have the prices of output difference multiplied by Q once we factor them out. And we can do something similar with the bottom expression as well, except instead of factoring QT and LT out, we're going to factor QS and LS out very similar. Right? And hopefully now you're starting to recognize, okay, well, it looks like we have the difference in the prices between the periods, right, that I'm highlighting in yellow. Those terms look like they're both the same on both sides of the inequality. And the next thing I'm going to do, okay, is just relabel the terms in yellow. Okay, PT minus PS, right, WT minus WS. Let's just call those the change in P and the change in W. Same equation. Hopefully you agree that the left side here is still all the terms that we have in orange. The right-hand side are still all those terms that we have in brown. And if we're maximizing profits in both periods, this has to be true. The next thing I'm going to do is I'm going to just move all of the terms to the left-hand side. Let's move them all to the left. Okay. And hopefully you can recognize here, I've done some factoring, right? QT and QS are both multiplied by delta P. So if I subtracted the delta P over to the left, we're going to get QT minus QS that we can factor out. Similarly, we get an LT minus an LS that we can factor out on both sides. Hey, anyone want to take a guess at what we're going to do with QT minus QS and LT minus LS? Yeah, those are just the changes, kind of like just how we did the changes in the prices a moment ago. Okay, so this is going to leave us with the following comparative static condition. And if you'd like, you can add the negative term back over to the right if you want. Now, I want to be clear. If we had multiple outputs and multiple inputs, multiple outputs, multiple inputs, okay. Right now, we only have one output and one input, but if we did have more, we would go through the same steps. We'd wind up here, except we would be summing over multiple outputs and we would be summing over multiple inputs. So if you're, looking at the problem set questions, for example, that have multiple inputs and outputs, and you're like, oh, how does this apply to that? You should be able to follow exactly the same steps to get there. Okay. So this applies very nicely, not just to our three-dimensional technology where we're producing one output, but even technologies where there's multiple outputs being produced. Okay. Now, all I'm going to do here is I'm going to add that delta W times delta L over to the other side. But this condition here defines for us all of the restrictions that must hold under profit maximization. Which means if you give me numbers for the data, I can plug that in here and I can check, does this condition hold or not? Okay. If we plug in actual data and we see, hey, this condition doesn't hold, then what does that tell us? That condition does not hold. Just think about it. The condition was that I'm maximizing profits in both periods. So if that condition doesn't hold, it means the firm did what? Yeah, they must have made some inoptimal choice. Okay, so this is a very nice way of using the system of inequalities to verify whether or not the observable data of the firm is consistent with respect to profit maximization over time. And again, there was an important assumption we were making in using this treatment, and that was we were assuming that the underlying technology was not changing. If it was changing, then what might have been profit maximizing in one case no longer is in another, and there's very little we can do. So what I want us to do here is wrap up this segment on profit maximization before we start getting into the next part of the course, which is going to focus on a partial equilibrium analysis, which is actually kind of a nice review of things you would see maybe in Econ 1, but with the intermediate mechanics, machinery behind it. So let's go ahead here. And remembering this profit maximizing condition, let's consider the following. Suppose the price of output goes up by $2, and at the same time, the price of labor goes up by $5. Okay. Let's suppose the firm responds by hiring fewer workers. Right. So I want you to think about all the information we're given here. Okay. $2. What does that value correspond to above? Yeah, that's right. That is our delta P value. Okay, and then $5 got to be our delta W value. They're both positive, agreed? They're both increases. If they were decreases, I'd plug in negative values. Okay, and the firm responds by hiring 4 fewer workers. Okay, so 4 fewer workers, that's telling me about what? Yes, very good. That is our delta L. So hopefully you're like, oh, it looks like he gave me, 3 parts of this inequality. I should be able to use those 3 values, plug them in, and I can find some condition on the variable that's remaining, right? They're asking us, what must happen to the optimal supply? Okay, right? If the firms are maximizing profit. Right? So here's what we're given. Right? Delta W is 5, delta P is 5. If they're hiring 4 fewer workers, right, then we know delta L has got to be -4. So we can substitute those into that inequality, and we get 2 times delta Q on the left has to be greater than -20 on the right. If I divide both sides by 2, okay, then this will tell us what has to be true about the firm's output decision so that we're not violating any of those profit maximization conditions. So this should give us a constraint on what must happen to the quantity. What is that constraint that's implied here? Yeah, very good. It has to be the case that delta Q has to be at least as big as -10. Meaning, if the firm had increased its output, it would not violate the profit maximizing conditions. Even if the firm dropped its output, it's possible it would not violate those conditions as long as the drop in output is not too big. Okay. How big? It cannot go down by more than 10. If the output was to drop by more than 10, then we could say, hey, that firm's behavior is not consistent with profit maximization in at least one of those periods. So this is a very powerful idea here, this weak axiom of revealed profit maximization, where we can actually use data and a consistency criteria, assuming the technological process is not changing over time, in order to think about what has to be true if profit maximization is satisfied in both periods. So with that being said, that wraps up, that concludes the part of the course that was focusing specifically on profit maximization. What we're going to start to do is revisit our consumer theory, and we're going to take the pieces of consumer theory that we know from 100A. We're going to take the pieces of producer theory from 100B, and we're going to put them together to think about analyzing market behavior in a single market. Now, the single market treatment is what we often refer to as partial equilibrium analysis. And partial equilibrium analysis, this is something that you've been doing your whole career in economics, right? Anytime you look at a single supply and demand diagram, right, for one market, you're conducting what is known as partial equilibrium analysis. You're not looking at the full economy. You're not looking at the full ripple effect. You're looking at just what happens in this one market. And if there's any spillover activity, we don't really follow that, if you will. It's a somewhat limited perspective. But what I want us to do is make sure we're comfortable from this particular perspective. And then what we're going to introduce, not next week, but the following week, is a framework known as general equilibrium analysis, where we will be able to model the entire economy, all of the markets at once, capturing the idea that when something happens in the market for Pepsi, there's this ripple effect that affects the market for Coke, which affects the market for Mountain Dew, which affects the market for Sprite, in a way where we can look at all of the markets together, not just one at a time in isolation. So the agenda for today, we're going to take a recap of the competitive market model, make sure we're kind of clear about the assumptions, and then we're going to jump right into revisiting this partial equilibrium framework in perfect competition. And we're going to make sure we have a good idea of this surplus maximization result. This is essentially Adam Smith's invisible hand. We want to understand how this result works in the perfectly competitive framework. And then we want to also realize that if any of the assumptions about perfect competition don't hold, then this result, which is a nice result, often I would argue is misused, that will not work if the market's not perfectly competitive. So if you're a free market person, you're like, I hate government intervention, and you're like, it's always better to have a free market. That's not the right idea, unfortunately. The idea we really want to think about is markets are different. Some markets work well, some markets don't. If markets work well, we don't need a lot of intervention in those markets. But if markets don't work well, if they're subject to what we call market failures, which you will spend a lot of time discussing in Econ 100C, things like monopolization, externalities, public goods and common property resources, asymmetrically informed agents, those things will not work in conjunction with free market policies. We will see that the total surplus in the market, right, the benefit from the gains in trade, decrease naturally if you have any source of market failure present. So unfortunately, Adam Smith's invisible hand result, it's a nice idea, but it's confined to a reality that doesn't really describe the actual world we live in. It's an oversimplification. So all of these free market policies that focus on like deregulation, cutting taxes, getting rid of subsidies, okay, getting rid of restrictions on what you can do, right, getting rid of vaccine mandates, okay, deregulation across the board is not necessarily an optimal policy. And that idea is predicated on a result that is not built from a realistic model. All right, so I want to take some time to kind of talk about where we've come from in the intermediate microsequence, right? You started with consumer theory, where your fundamental modeling tool, right, of modeling preferences was a utility function, right? That was the abstract notion that we used in 100A. And given that utility function, which modeled preferences, the idea was we face some sort of budgetary constraint. And our model of describing consumer behavior was that the consumer is going to optimize their utility subject to that constraint. And this was exactly the process that we used to think about where the individual consumer demand was coming from, at least the Marshallian demand curve. Okay, once we knew how one consumer's demand was formulated, we could add up the demand across all the consumers in the market to figure out the market demand curve. Okay, and that was pretty much what you had done in 100A. In 100B, right, we started also with an abstract notion of modeling, not preferences, but technology. And instead of using utility functions, the way we modeled technological relationships was utilizing production functions. We didn't have budget constraints constraining firm behavior, but we had what type of constraints? Yeah, we had technological constraints, absolutely. Okay, so rather than thinking about a utility maximizing consumer, right, to explain where a demand curve comes from, our model was of a profit maximizing technologically constrained producer. And we were able to solve the profit maximization problem from the perspective of the firm and see how this is related to the generation of the firm's individual optimal supply rule. In a past segment, we thought about taking the demand curve for one firm in perfect competition, recognizing all the firms were the same in perfect competition, and then we aggregated, we added up all of the individual supplies to then generate the market supply curve. Once we have our market demand curve and our market supply curve, we are ready to conduct partial equilibrium analysis by graphing that demand curve and that supply curve and thinking back to the Econ 1 framework and perfect competition. So before we do that, and with a numerical example, I want to talk a little bit about the assumptions that are inherent in our perfectly competitive market model. Okay, and I think the more we discuss this, the more you're going to see that the perfect competition, our supply demand framework, is not really well grounded in reality. It is more well grounded in simplicity. And the reason why economists like to simplify things is because it makes them easier to interpret and understand. So I want to be clear. In Econ 1, the first model you really learn after your production possibilities is you learn this perfectly competitive model of supply and demand. We don't start with that because it's realistic. In fact, real things, the more realistic they are, often the more complicated they are. And that's not where we want to start. We start you off with perfect competition, not because it's real, but because it's easy, it's simple, right? For example, we assume in perfect competition, everyone behaves in a very simple way, right? What is that behavior? All the buyers behave this way, all the sellers behave this way. They behave how? Yeah, that's right. They go into the store, they look at the price, and they decide how much they're going to buy, recognizing they cannot affect the price. Right? What was the word we used to describe that behavior? 2 words, really. Right? Buyers and sellers behave like what? Yeah, no, that's exactly right. They behave like price takers. That's a hugely simplifying assumption, right? No one negotiates. Buyers don't negotiate. Sellers don't negotiate. They just look at the price and they're going to pay sticker price. Okay, so what I want you to think about here is if we took all the different types of industries you've seen and we line them up on the left where you have the most competition you would ever see in a market towards the left end of the spectrum, towards the right end of the spectrum, you have the least amount of competition between sellers. Similarly, as we move to the left, if I face more and more competition, I'm going to argue that also means we face less and less market power. We have a less ability to set the price if there is more competition against us. Conversely, if I have less and less competition and I'm moving towards the right end of the spectrum, right, then I should have a better ability to actually exert market power and control the price. In fact, I think we know what's all the way to the right. What is all the way on the right side of this spectrum here? As far as you can go. Like, what's the least amount of competition you can have? None, right? So yeah, very good, folks. That would be the monopoly. Okay? And we don't do a lot of monopoly in this class. 100C will focus pretty excruciatingly on monopoly, right? Different pricing strategies, trying to extract as much profit as you can from your consumer base. Now, what I want us to think about is what's on the other end of that spectrum, right? All the way to the left. Okay, we have the most competition you can even think of. Okay, what's the least amount of market power firms and buyers can have? The least amount you can have is 0. And that's what we think about when we're building this perfectly competitive market model. Yeah, very good, Dylan. That's right. Okay, so hopefully you remember why the buyers and the sellers are behaving like price takers in this model. It's not because we assume that. What we assume is that the buyers are so numerous, that they recognize this, kind of like when you're in the grocery store. There are so many other buyers, you know, you can't really negotiate at the checkout. If you don't want to pay that price, somebody else will. So the behavioral implication of this, was that if there were so many buyers that each buyer was a drop in the bucket, those buyers behave like price takers. Okay? And I'm going to maintain this assumption throughout the spectrum here. Okay? What's obviously different is the assumption about the number of sellers. Agreed? Right, the far left, we have many sellers, which is why the sellers behave like price takers. But as I move across that spectrum to the right side, right, at the far right, we only literally have one. And that seller is not a price taker. That seller is a price setter. Or price maker if you want to run. Now, I want to think back to the left side of the spectrum again. Let's move back to the left over here. If we're really dealing with a thought experiment, thinking about what setting would generate the most competition between the market agents. Okay? Are the firms selling different products, or must they be selling similar products? And this is something we've discussed before as well. If you're in perfect competition, are the firms selling different products, or are they selling similar products? What do you think? Like if you're selling trees and I'm selling computers, different, right? Are we in competition for one another? Yeah, you're in the tree market, I'm in the computer market. We're not, there's no overlap there. So hopefully you would agree that does not describe the left end of the spectrum very well. Okay, the left end, all the way at the left, is the most competition we can have between firms. So hopefully you're thinking, okay, well, maybe like Pepsi and Coke has a bigger overlap. They're more similar, right? They would face more competition. I would agree. That moves us farther to the left. But I'm going to argue that if we can make the goods similar, and that gives us more competition, then the most competition we could have corresponds to not just the goods being similar, but them actually being what? Right, all the way to the left, the most competition we can have, not just similar goods, but what? Yeah, they should literally be identical. Identical goods. Okay, not Pepsi and Coke. Not Pepsi and Coke. Those are not identical goods. You might say, yeah, they are. Okay, I would counter that. I would say there's folks in the class that will only drink Pepsi regardless of how cheap Coca-Cola is. Okay, and there are some people in the class that will only drink Coca-Cola no matter how cheap Pepsi is, right? They like the red can. They like seeing the polar bears at Christmas time. Okay, they're not the same goods. They're branded differently. Even though the stuff in the can is maybe exactly the same, the branding matters. So when we're talking about perfect competition, not only are the products identical, but literally the technologies we said have to be exactly the same. Okay. Yeah, Dylan, you bring up a really good question. So the question is, isn't soda kind of like a monopoly since Pepsi is the only company selling Pepsi products and Coke is the only company selling Coke products? I will argue the following, that as soon as you brand your product, you now have a monopoly over that brand. You're the only person selling Crest toothpaste. Okay. Does that mean you're a monopolist in the toothpaste industry? Answer is no. But you are with respect to your particular brand. You're the only company selling that brand. So in perfect competition, can we even have Pepsi and Coke? Answer is not really. Okay. Products have to be identical. Same quality, same branding, same temporal features, spatial features. Okay. Very extreme assumption. Okay, hopefully you're like, oh, that's not realistic. I agree, because we know products have slight differences. Okay, but perfect competition is not a reality. It is a thought experiment. What if? It's a hypothetical. Are there any markets that satisfy all these assumptions? I would go as far as to say probably not. Okay, you find a market that you think is perfectly competitive, I could probably point out a few reasons why we're probably not all the way to the left in this picture, while we're maybe towards the center. Okay. Furthermore, if you have a totally unique product, let's think about the opposite. If you have a totally unique product, who must you be? It's totally unique. You're the only one selling it. Is that right? Where must you be on the spectrum? You got to be on the far right. If you're selling a totally unique product, then you're the only one selling that product, which means you have a monopoly over that product space. Okay, so you can start to think about, man, what strategies can I use to maybe improve my monopoly position? Okay, differentiating your product. If you read Michael Porter's 5 Forces, it talks about some important things to help you improve your monopoly position. One of them has to do with making your product look different. Right. Another big assumption that we have in the long run, we assume that if a firm wants to enter, right, as an outsider, they can do this. If a firm wants to leave as an insider, they could do this. There's nothing preventing that from happening. Okay, and the long run implications of this assumption were that profits would get driven to what? That long run equilibrium. What happens to profits from this process of entry and exit? Gets driven towards, yeah, it's getting driven towards zero. Absolutely. Okay. However, is it possible that we have the same assumption at the far right end of the spectrum? What happens if a firm enters? Can we have the same assumption on the right side of the spectrum? Okay, I see folks are saying, nope, can't happen. Because if one more firm were to enter, then we don't have a monopoly anymore, right? It's a duopoly. Meaning there has to be something preventing other firms from entering. It could be technological entry barriers, like having to pay really high fixed costs to set up your infrastructure. Okay. Maybe you have legal barriers to entry, right? This company owns all the coal in the region. If I want to start a power plant over here, I don't have the right to any of that coal to buy. Okay. Or maybe a product is patented. And because it's patented, I can't use that idea. I can't enter that industry yet. It's keeping other people out. The implication of entry barriers is that if you're making profit in the short run, there's no mechanism that's going to drive those profits to zero anymore in the long run. So just to be clear, the entire 100 A and B series has been really operating under these assumptions on the left, which I'm arguing here is not very realistic. Okay. What's more realistic, perfect competition or monopoly? It's an interesting thing to think about. For example, how do I know like my watch is real? How do I know that this is real? Yeah, like we can observe it, right? It exists. So what's more realistic, perfect competition or monopoly? Do we have monopolies? Maybe that's a better question to ask. Are there such things as monopolies? Sure. Okay, if I ask you though, can you identify a perfectly competitive industry? That's probably way harder. Okay, so I would argue monopoly is more reality. Perfect competition though, not realistic, but simple. You will definitely consider monopoly in what I think is a fairly painstaking amount of detail if you do take the third part of the intermediate sequence. Okay, in that part of the sequence, you look at what happens if any of these assumptions break down. That's really what 100C is about. If any of those assumptions break and we're not in perfect competition, what does imperfectly competitive behavior look like? All right, now back to this idea of partial equilibrium analysis. When we're applying partial equilibrium analysis, what we're essentially doing is we're looking at a slice of the whole economy. We're looking at just a single market at a time. So here is a partial equilibrium perspective. Right, and given the demand and supply curves in this market, we can make predictions about things like how the market equilibrium evolves in this market. If I want to know what happens in some different market, though, we can't really see that with this diagram alone. We would need to consider partially the other market diagram. And as a consequence of that, the analysis is a little bit limited in this regard. We can look at what happens in a single market, but when it comes to looking at the ripple effect of that behavior, we have a few things we try to do, like think about curve shifters when other prices of other goods change, but that's about it. Okay. So this provides very little consideration for the ripple effect across markets, which we know is a very salient part of reality, right? The price of Coke changes, that affects the demand for Pepsi, which affects the price of Pepsi, which affects the price, there's a big ripple effect across markets. And with partial equilibrium analysis, we're really only considering what are arguably first order effects of changes in the overall economic environment. Despite that being the case, this type of framework was pretty reasonable for developing a lot of conceptual ideas, things like consumer surplus, producer surplus, the notion of equilibrium, shortages, right? We were able to define all these concepts in this framework. Even though the framework isn't totally realistic, it still gave us some bite to be able to talk about quite a bit in terms of fundamentals. So what we're going to do here is we're going to revisit some 100A material, okay? And we're going to use a model from 100A to think about generating the market demand curve. We're going to use a model from 100B to think about generating the market supply curve. And then we'll be able to put those pieces together to discuss the equilibrium in that market. So here is a first example. Let's suppose we have a market with 2,000 identical consumers, each with symmetric Cobb-Douglas preferences. All right. Now, let's suppose these consumers face some prices, they face some budget constraints, right? So we can solve the utility maximization problem. And if you do that for Cobb-Douglas, hopefully you recognize these forms here. This would be my demand for good X, and I over 2px. My demand for good Y is I over 2py. Okay. So we solved utility maximization. We can figure out what the demand is for one good for a single consumer. Now, in taking our partial equilibrium approach here, what we're going to do is we're going to focus specifically on one market. Okay. Let's focus on the market for good X. If one consumer is going to consume I over 2px units, right? That is the demand of one single consumer, right? Was I over 2px. If we have 2,000 of those consumers and they're identical, then we should be able to, I think, pretty easily compute the total market demand. with that income and that price. Right? All we have to do is take the single demand and do what to it? Yeah, just multiply it by 2,000. That's it. So our total demand, right? All we're doing here is we're taking the 2,000 people and we're multiplying that by the demand that a single one of them has. And we can do this given they're identical. If we had non-identical buyers, then we would just add up the individual demands. Okay, so what we can do here now is we can multiply by 2,000, and we can see here the equation for the total market demand curve is 1,000 I over PX. So if you plugged in an income value, you could graph the demand curve pretty easily, right? Like if I was 50, you would have 50,000 over PX. You could graph that demand curve. It would look like this. Okay, so we've generated the demand curve here using utility maximization. What about the other side of the market? Well, hopefully that is familiar, considering we've been dealing with this for the past 2.5 weeks through profit maximization. But let's suppose there are 100 identical price-taking firms producing good X, and each firm's production technology for good X, let's suppose, is this decreasing returns to scale Cobb-Douglas, which we know has a well-defined profit max solution because it is DRS. If we solve the profit maximization problem for this firm, and then that will yield for us the optimal supply rule. And so again, I've kind of suppressed a little bit of the work here. I would recommend, if you're, you don't see these steps, go back and make sure you're working through them at home so you can generate this yourself. But this is the supply curve for one firm. Okay, if we want to aggregate and consider the full market supply, then we have to take the supply for one firm and we have to do what to it? Yeah, that's right. We're going to multiply a single firm supply by the number of firms, just like we had done to get the market supply curve in past segments. So we can do that here. Now let's take 100 times the single supply curve. You'll notice the 100 and the 4 will cancel, leaving us with a 25. So this whole expression here is the market supply curve equation. Okay, so I'm going to suggest now we can pretty much fully describe the partial equilibrium framework in the market for good X. Okay. Quantity supplied is 25 PX over the square root of the product of the input prices. Quantity demanded in total was 1,000 I over PX. So what we should be able to do now is kind of see, hey, if I have the quantity supplied and the quantity demanded, if I wanted to find out the equilibrium, I can set them equal to each other to do this. All right, so let's go ahead and think about doing this. Okay, let's suppose the consumers have $10 of income. So we're going to plug in a 10 for I over here. Okay, 10 goes in. Okay, we're also going to be given the input prices. W and R are both equal to 1. So we're going to plug that in down here for W and for R. Both are equal to 1. Okay. And once we do this, right, we get 25 PX will be the equation of the supply curve. And 10,000 over PX will be the equation of the demand curve. Right, we have the supply curve equation in the dark blue on the left. We have the demand curve equation in purple on the right. Okay, so all we're doing, supply equals demand. And you'll notice almost right away, I can solve this for PX fairly easily, right? We have one equation, we have one variable PX. So if we multiply both sides by px, divide both sides by 25, you should get px squared equals 400, which means the equilibrium price in this market, right, given the other factors here, has to be what? Yeah, very good. Got to be 20 bucks. If you take that 20 and you substitute it either into the demand curve or into the supply curve, shouldn't matter which one because we set them equal. Okay, what is the equilibrium quantity in this market? Price is 20. What's Q star have to be? Yeah, very good. Got to be 500 units. I should maybe have an X subscript here since we're talking about the quantity in equilibrium for good X specifically. Okay, so this is us utilizing our micro theory fundamentals, right? Utility function, production function, describe preferences and technologies. Given the prices, we can generate the market demand curve, we can generate the market supply curve, and we're able to think about quantifying the equilibrium in those markets that would prevail. All right, now, hopefully you're familiar with what happens if we nudge the market out of equilibrium. Okay, for example, let's suppose the price is artificially high above equilibrium. Okay, if that happens, anybody remember the situation we would find ourselves in when you compare the quantity supplied to the quantity demanded? Yeah, that's right. There's excess supply, which is the same thing as a what? Remember what we called that in Econ 1? Measure this distance. Yeah, very good, Luan. It's a surplus. Okay, and when the price was above equilibrium, we recognized, oh, there's excess supply in the market at that price. Because of that, right, what happens to the sellers? They are not able to sell all their inventory, right? Their shelves start getting stocked up. And I would argue that's costly for not one, but two reasons, right? There's an opportunity cost of shelf space that's not being used, right? If I sold my product, I could put something else in that space and sell that. But the fact I have an inventory buildup means I'm missing out on that opportunity. If you have enough inventory, you might even have to store that in some sort of a warehouse, right? Like if you're Bezos, you got to buy a lot of warehouses to store that inventory. And because that inventory buildup is costly, this incentivizes collectively sellers to put downward pressure on that price. Okay? And that is going to restore the price towards the equilibrium. If the market was nudged up out of equilibrium, what happens? Well, sellers start putting downward pressure on that price and it restores the equilibrium. And we can make a similar argument if the price was artificially low. Right? Like if the price is too low, then which situation does that induce? And here the demand exceeds the supply. That's a what? Yeah, very good. That is absolutely a shortage. Excess demand relative to supply. Okay, in this situation, okay, I would argue that some buyers who are not getting the good, right, are going to start bidding up. They're like, oh, he's only paying $1. I'll pay you $1.01. Start outbidding each other. Okay, and that starts to put upward pressure on that market price. And firms are more than happy to accommodate that pressure, right? Higher prices means they're going to be taking in higher margin, more profits. So the argument here is if the price is artificially low, right, we nudge it away from equilibrium over time, what's going to happen? It's going to restore. Now, in terms of this adjustment to equilibrium, what did the policymakers have to do in order to push the market back to equilibrium? What does the government need to do to push the market to equilibrium? What do you think? So I'm going to argue not ceilings and floors. Those are things that would keep us from reaching equilibrium, right? Those restrict the market from reaching equilibrium. So the government doesn't need to do that. That'll do exactly the opposite of what we wanted if the goal was to move the market to equilibrium. So we don't need ceilings and floors. We don't need taxes or subsidies. Those would move the market away from equilibrium. And we're going to revisit that as well if you're not sure about that. Okay, so what does the government have to do? Like a moment ago, when we were talking about the adjustment process, did I say the government had to do anything? Skylar, and I like what you're saying. Rachel, I like what you're saying too. If you're saying that the government doesn't really need to do anything, that is the answer that I'm looking for. Okay. Not interest rates. In fact, the government does not control interest rates. The Federal Reserve does that, and the Federal Reserve is not a part of the government. Okay, if you take macro, you will learn more about that. Kind of a shady institution. So here's my point. When the market's out of equilibrium, the government doesn't have to really do anything. It was the incentives of self-interested buyers and sellers that pressured us back towards the equilibrium. The government didn't have to do anything. Now, this doesn't mean we don't need government. I want to be clear about that. The least amount of regulation is not zero regulations. Every market is predicated on a set of rules. Every market is predicated on a set of regulations that describe what sellers are allowed to do and what buyers are allowed to do. Every market. And the least amount of rules that you can have where the market will still work is property rights. If you do not have property rights, if I can just come and take your stuff and you have no legal mechanism, right, to keep that from happening, then a market will not work. What does it mean to sell something if you can't even claim ownership over something? So I want to be clear about this. Okay, what we're looking at is Adam Smith's invisible hand result. This is the mechanism by which self-interested agents, right, guide the market to an allocation that has some desirable properties. Okay, this is exactly that mechanism. So I want to be clear. The lesson here is not we don't need government. In fact, I would say it's exactly the opposite. We definitely need government to define, enforce, and protect what? At minimum, for a market to even work, we need the government to define, enforce, and protect what? Yeah, they gotta protect your property rights. Okay. So let's think about that. Enforce property rights. Anybody know the branch of the government that's responsible for enforcing laws? Yeah, it used to be headed up by that big orange guy, really loud, obnoxious orange guy. Yeah, that was the executive branch. That's right. Okay, executive branch, police force, right? Those are involved in enforcing laws. Okay, which branch of government defines the law? Yeah, legislative branch, right? All those folks in Congress that don't really do much otherwise, right? They're the ones who define the laws, who write them. Okay, who interprets the law? judiciary. So I'm going to argue we need all three of those things in order for property rights to be protected. But aside from that, we do not need the government to do much else. Okay? Provided, of course, we're in a perfectly competitive market, which I think I've argued is not very realistic at this point. Okay, so that adjustment towards equilibrium, right? That was happening on its own without the government needing to force anyone to do anything. Okay, and the reason why we refer to this as an equilibrium is, as we've mentioned before, an equilibrium is a situation where no one wants to change their behavior. And I would argue in the equilibrium, sellers don't have any incentive to push the price down because there's no surplus, and buyers have no incentive to try to bid the price up because there's no shortage. Okay, so what we want to do moving forward, and we're going to get to this on likely on Tuesday of next week, is we want to understand that the equilibrium in this competitive market model, it has a very nice property. And that is, if you think about the total amount of surplus that's generated, the consumer surplus plus the producer surplus, the total amount of market surplus in the equilibrium, it turns out that that is as large as it could possibly be. And this is really the second caveat to Adam Smith's result, is that when that invisible hand guides the market to P star and Q star, that makes the economic pie as big as possible. It maximizes the gains from trade between buyers and sellers. That's why folks say things like, oh, free markets are efficient. They are if they're perfectly competitive. But if you have a monopoly and you take away all the rules, guess what the monopoly is going to do? They're going to try to take a bigger chunk of that pie from the consumers. Okay, and that effort actually causes the pie to shrink. Okay, so we're going to look at this results that if you compute the total surplus, that we can show that if you try to maximize that total surplus, the solution to that problem is to have the buyers and sellers trade exactly Q star units. Okay, so this is really the invisible hand result, right? That if you allow people to go in there and be selfish, that those pressures, those incentives push the market to equilibrium, and the equilibrium makes the economic pie as big as possible. Now, there's a group of folks, let's just say on the right, maybe. This tends to be on the more conservative side with respect to intervening in markets, that abuse this result all the time. They try to say, hey, we should apply this idea everywhere, free market everywhere, without realizing the reality that some markets work well and some don't. Okay, and they further try to suggest that this makes me being greedy a good thing. Right? They try to say, oh, this means profit maximizing. Being greedy is actually good. It pushes the market to this allocation. It makes the pie big. That is a gross misstatement, and it's an abuse of this result to try to push a political agenda. All right, now back to our discussion of surplus. Hopefully you remember consumer surplus. And we can think about inverting the demand curve, right? The demand curve measures the quantity demanded as a function of price. But if we were to solve for P, just like with the supply curve, you remember in the lecture survey question, we solved for P on the supply curve, that gave us the marginal cost curve. If you solve for P with the demand curve, that will give you the dollar value marginal benefit function. Right? The demand curve measures the value to the buyer on any unit that they're going to purchase. That's exactly what a demand curve does. Okay, and the value, right? What is that reflecting? That is reflecting the maximum amount the consumer is willing to pay for a particular unit. Okay, so if you look at, what's the value of this consumer for the fourth unit in the market, we can go up to the demand curve. And we can measure that price and say, hey, that dollar value is the marginal benefit of consuming the 4th unit. If I wanted to know how much is the 10th unit worth to the buyer, okay, then we plug in the 10th unit to the demand curve and we can calculate the marginal benefit of the 10th unit. Okay, now consumer surplus, right? The way we're going to think about this, if the buyer consumes Q units, is we could compute the total benefit by adding up those marginal benefits, right? That's the total benefit. But this is not the consumer surplus because we have to still subtract out what? Yeah, that's right. We have to subtract out how much the buyer actually pays. If I gave this buyer Q units for free, the blue area would be their surplus if I didn't charge them anything. But if they actually paid P dollars for each unit, right? Like think about why they stopped at Q. Okay, they stopped at Q because they were facing a price of P. So the way we get consumer surplus is we take the total benefit in blue and we subtract out how much the consumers actually paid. And what we're left with then is that Marshallian consumer surplus, right? The difference between a marginal benefit and the price on each unit added up over each unit. That is exactly how we've defined the consumer surplus in 100A. And this is specifically Marshallian surplus. You might remember in 100A, depending on using the Marshallian demand curve or the Hicksian demand curve, there were different surplus measures, equivalent variation, area variation, compensating variation. I'm just going to use straight Marshallian surplus here. Okay, so there is our consumer surplus. Now, hopefully, producer surplus is pretty quick to recall, right? We can take the supply curve, we can invert the supply curve to give us our marginal cost function, just like what we had done in the lecture survey question today, first using Hotelling's lemma to get the supply curve. And we can rewrite this as our marginal cost. Right, there it is. Okay, and then we recognized, well, supply curve is really measuring the marginal cost of each unit from the seller's perspective. And we can think of that as being a reflection of the seller's minimum willingness to accept payment, right? Demand curve measured the buyer's maximum willingness to pay, right? Their value. The supply curve, though, is measuring the cost of that unit, which is the least amount a seller should ever accept if they're rational, right? If they don't want to sell something at a loss. So we recognized here that if you were to plug in the 12th unit, we go up to the supply curve. That tells us the marginal cost of producing the 12th unit. If we plugged in the 25th unit and we go up to the supply curve, that tells us the cost to the seller producing the 25th unit. Okay, so hopefully you remember, if we integrate under that marginal cost curve, we're adding up the variable cost of each unit. So the area underneath the MC curve is not total cost, it is the total variable cost. It is the total variable cost of producing Q units. Which means if we wanted to calculate producer surplus, all we have to do is take the benefit from the seller's perspective, which was the revenue, that was the cost from the buyer's perspective on surplus, and we subtract the total variable cost from the green area, right? We take total revenue in green minus the TVC in the blue, and what will that leave us behind? It should leave us with our definition, our notion of the producer surplus, right? We took the difference between the price and the variable cost of every single unit, right? That's our marginal profit, and we added those up. That leaves us with our producer surplus. So producer surplus is the seller's piece of the pie. Consumer surplus is the buyer's piece of the pie. If there's no government taking a piece, right, through either taxation or maybe subsidization, then the way we calculate the total surplus in the absence of any other government intervention is just by adding up the consumer surplus and the producer surplus. Now, consumer surplus. This was the total benefit that the buyer gets minus what they pay, which was the revenue. The producer surplus was the total revenue that the firms receive minus the variable cost that they pay to produce those goods. If you look carefully, you should recognize something cancels here. And that is what? Yeah, very good. That is the total revenue terms. They're gone. And there's an important idea kind of built into this. The only one of these terms where the price shows up is the total revenue terms. And they're gone. So I'm going to argue that the total surplus doesn't really depend on P. Like P might affect which Q you choose, but the total surplus is really a function of the quantity that is traded. And we can equivalently write this as the integral between the marginal benefit and the marginal cost curve, the area between the marginal benefit curve, the demand curve, and the marginal cost curve, the supply curve. So you should note here that total surplus does not depend on the price, right? The price shows up in total revenue, but total revenue canceled from both terms. Okay, so what we want to do next class is really make sure we understand this result, that if we wanted to solve the problem of maximizing total surplus, of maximizing this dollar value gain from trade in total, right? Maximizing the economic pie. Hey, what we're going to show next time is that the solution to this problem is the equilibrium quantity. And I think that is a good place for us to wrap things up tonight. So if you have any questions, feel free to drop them in the chat. We'll do a little bit of rapid fire Q&A. Otherwise, you should be good to go for that quiz on Monday. LRP should be available after class at 8. Make sure you get those LSQs in. And if you have any questions about the regrading on that week 6 quiz, Kimmy is handling those. So please reach out to her. But as far as I had seen today, it looked like things were updated appropriately. So just double check that on your own. You should see those fudge points at the very bottom of the quiz. You won't see the actual questions corrected. They'll still look wrong. But at the very bottom, you should see there's fudge points added to bring you back up for those 2 regrade problems. Good question. Do we have class next Thursday for Veterans Day? I believe the university is closed, so we will not have class next Thursday. I'm also anticipating we will probably not have class on the Tuesday of the Thanksgiving week. Okay, but don't hold me to that yet. I will know that more precisely next week. So I'm going to try to give everyone off the whole week for Thanksgiving, because I think we are just where we need to be in the material at this point. So if there are no other questions, I will bid you farewell for the evening. Have a wonderful weekend. Get those deliverables in. Stay tuned for that quiz on Monday. And I will see you all in class, same time, same place on Tuesday.